David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen.
Today's lesson covers Venn diagrams and something called the addition rule. And this is a rule that we use to calculate the probability with a union, which is the OR condition. So what it is the probability of A or B, that's the union, is going to be the probability of A plus the probability of B, but you have to subtract the intersection of the two probabilities. Now, pause the video and think about that for just a minute. All right, so I drew a very simple Venn diagram which shows the circle for the probability of A, our circle for the probability of B, and then I've marked the intersection. And so this should show you why we have to subtract the intersection after we add the two, because check it out. This part is part of A, this part is also part of B. So if we just add A and B, we're adding this region twice. And so we're going to overestimate the probability of A or B. So that's why we have this little subtraction part for the intersection. Okay, here's a very straightforward example. No Venn diagram here, I'm just giving you probabilities. So the probability of event A is 0.5, the probability of event B is 0.4, and the probability of the intersection, both A and B occurring at the same time, is 0.2. Now quickly pause the video and calculate the probability of A or B. Very straightforward. You just add the probability of A to the probability of B, subtract the probability of them both occurring at the same time, the intersection, and you're going to get 0.7. All right, let's do a little bit more of a complicated example. So here's your Venn diagram with event R and event S. And then probabilities are given in fractions here, so that's going to add a little bit of a wrinkle. You should be able to manipulate your fractions just fine. That's assumed prior knowledge for this course. So check it out. The probability of event R alone, without S occurring also, is 1/8. Then the probability of the intersection, R and S occurring together, is 1/4. And then the probability of S occurring alone, without R at the same time, is 3/8. And then the probability of R or S not occurring is 1/4. So what I want you to do is pause the video, use the addition rule to calculate the probability of R or S, the union. All right, I did a full plug-in step. I didn't do any mathematics. So what I did is I did the probability of R. So that's 1/8 plus 1/4. So there's the probability of R. I subtracted the probability of the intersection. That's minus 1/4 there. And then finally I added the probability of S, which is 1/4 plus 3/8. So that's a perfect plug-in step. Go ahead, if you haven't gotten that one, now you have it. Pause the video and find the probability of R or S. Okay, if you add all those fractions together, you're going to get 3/4. So make sure you can do that. I did that one in my head. If you need to put it into like terms, you can just turn all of these into eighths and then add them up. You're going to get 6/8, which reduces down to 3/4. All right, so here's a more complicated IB style question using Venn diagrams and the addition rule. So I drew my Venn diagram because I'm going to use it. It's going to be helpful. If you're prompted to do that, make sure you do that. So I have my two events, our event R and event S. I drew my circles with my overlap with my intersection. Now I'm given some things. I'm given that the probability of event R is 3/8, the probability of event S is 5/8, and the probability of R or S, the union, is 3/4. Now pause the video. What from this can you put on here? Is there anything you can do that? And the answer is no. The things on here have to be R only, the intersection of R and S, or S only, or none of them. And none of these are given to you. So our first step here is going to be to find the probability of the intersection. And we can use this rule to do that. Okay, so we know this, and we know this. We just don't have the intersection. So go ahead and pause the video, write an expression that you can use to find the probability of the intersection of R and S. Okay, here's your plug-in step. You know the probability of the union. That's right here. That's the OR condition. So we've given that, we put it here. So that's what, in the addition rule, that's what goes on the left-hand side of the equal sign. So there we go. Now we do know the probability of R and the probability of S. So probability of R plus probability of S. Now to get the probability of the union, we have to subtract the intersection. I don't know what that is, but I know it goes right here in the equation. So now I have one unknown in my equation, so I can solve it for the probability of R intersection S. So pause the video. If you haven't done that already, pause the video and do that. All right, so here's how I did that. I have a negative on the probability of my intersection. So I moved this over to this side. I took my 3/4 and moved it over to that side. I changed all my fractions to eighths and I combined them and I get 1/4. So now I can put 1/4 right there. Okay, so now I'm getting close to being finished with my Venn diagram. In fact, that's what I want you to do now. I want you to populate the other 3 regions of this Venn diagram. All right, here's your next one. What I want you to do is find the probability of everything that's in R but not in S. Okay, so looking at our Venn diagram, pause the video and tell me what region you're going for. What region is this prompting you to find? Okay, so everything that's in R but not in S. So you're looking for this section that's R only. So now you have everything you need to do. Pause the video, find out what that probability is. All right, so I did my math. I did my probability of R total minus the probability of the intersection, which is these 2 numbers, and I get 1/8. So now I can add that to my probability diagram. Now I want you to find the probability of everything that's in S but not R. So pause the video, do that math, and put the fraction in the correct location on your Venn diagram. All right, so here's how I did that. I took the probability of S, the total probability of S, which is 5/8. I subtracted my intersection because that's also R occurring. So 5/8 minus 1/4 gives me 3/8, and I slap that on there. So now pause the video, consider whether you're done, and if you think you're not done, finish out this Venn diagram. Remember, all probabilities add up to 1 when you consider a full situation. So we know from the very beginning that the probability of the union of all 3 of these things is 3/4. So that means there has to be 1/4 that falls outside events R and S. So I put that there. All right, let's do a considerably more complicated IB style question that requires use of the addition rule and a little bit of critical thinking to boot. So here we go. Probability of A is 9/20. Probability of B is 3/10. Now, we're not given what the intersection or the union are. We're just given that the union, the OR condition, is twice the AND condition, or the intersection. So the probability of the union is twice the probability of the intersection. Now I've gone ahead and drawn up our Venn diagram because we're going to populate that with the correct probabilities in the correct places. So what I want you to do right now is pretend like you're sitting for a quiz or a test and you just got this question and the prompt is fill out the Venn diagram. I want you to think real hard and find out what your entry point is into performing this task. I'll give you a hint. The first thing to figure out is what is the probability of the intersection. Now, I'm not telling you how to do that yet, but you can use the rule, the addition rule, and you can do that so that you have only one unknown, and then you can solve for this. All right, so here's a first step. The probability of the union, according to our rule, is going to be the probability of event A plus the probability of event B plus the intersection of A and B. So there I have a workable equation, except I need to do one thing. There's a substitution that we can do that allows us to solve for the intersection. Pause the video, see if you can figure that out. Okay, here's the substitution. We know that the union is twice the intersection. So I'm just putting twice the intersection in here for the union. Same equation otherwise. Now we can solve this for the probability of the intersection. you haven't done that yet, pause the video and do that. So I just did a little bit of algebra. What I did is I subtracted my PA intersection B from my 2 PA intersection B, or actually I added, okay? So I got 3 of the intersections equals 15 over 20, divide through by 3, and I get 5 over 20 is the intersection. So now I can put that on my Venn diagram, and of course 5 over 20 is just 1/4. Okay, so now we have made a really good start on figuring out this, this Venn diagram. So what comes next? Pause the video and think about what you can figure out next. All right, the next thing you can figure out is the union. Super straightforward calculation. Pause the video, do that, come back. So the union is twice the intersection. If the intersection is 1/4, twice 1/4 is 1/2. So that's the union. Now, we can't put that on the diagram yet, right? Because the union is this plus that. We're gonna need to do a little bit more math to get there. But this allows us to put something else right on the diagram. Pause the video, think about what that is. So the union is everything inside the circles. So the complement of the union, meaning everything that's not inside the circles, is 1 minus the union. So if the total of these is 1/2, then that means that the complement is also going to be 1/2 because it's 1 minus 1/2. So we can put 1/2 right there outside. Okay, so now we just have to find the probability of A only and B only. I want you to pause the video and do both those calculations and come back. All right, so the next one to figure out is A only, which is the union, which is everything that's in A and not in B. So everything that's in A and not in B, that's this section here. And that's just going to be everything in A minus the intersection minus the quarter. So I did 9/20 minus 1/4. That's going to give us 4/20 or 1/5. So we can add that in right there. Finally, everything that's in B but not in A, that would be this notation here. And we're going to get everything in B, that's 3/10 minus 1/4, which is our intersection. And that's going to give us 1/20, which we can put in here. Now, what I want you to do is pause the video and perform a check. Are all those fractions correct? Do that and come back. So here's the check. Everything in here has to add up to 1. Okay, that's our rule for probability here. So 1/5 plus 1/4 plus 1/20 plus 1/2 must equal 1. I went ahead and converted these all to 20ths, and we end up at 20 over 20 or 1. So indeed, that is correct.
Now that you've finished watching the video, take a moment to jot down any questions you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.